Hello and welcome to another Physical Sciences 3 lecture. We're continuing on with our electrical energy work and we're on page 28 of the booklet. So we're looking at household electrical energy now, and we're talking about how we actually buy energy instead. So often the physics units are not usually useful, or they're not the most useful units in like everyday life. For example, when we're driving in a car, the units we usually use is kilometers per hour because they're more useful than meters per second. So we got a better idea. Similarly, in when we're talking about household electrical energy, we talk about it in kilowatt hours. Okay, and this is when so it's the energy when power is in kilowatts and time is in hours, not in watts and seconds instead. So often people will say they are buying power when they are, but you're actually buying electrical energy instead of power. So the first example is how many joules in 1 kilowatt hour. We did this in the other example. So E is equal to 1 kilowatt. So 1 kilowatt hour is equal to 1,000 watts times by 3,600 seconds. So 1 kilowatt is equal to 1,000 watts, and 1 hour is equal to 3,600 seconds. Okay, that's how we get our energy. So we can work that out to be 3.6 times 10 to the 6 joules, or 3.6 megajoules. Cool. Okay, so that's the number we use for converting again, 3.6. So an off-peak heater draws 6 kilowatts of electrical power for 720 hours over the winter. How many kilowatt hours has it used? Well, that's going to be energy is equal to 6.0 times 720 hours. And so if we go to our calculator, that's not our calculator, go to our calculator, we have 6.0 times by 720, and oops, we want times in there, times by 720, and that's equal to 4,320. Oops, can't write properly. 4,320 kilowatts hours. Okay, 4,320 kilowatt hours. What is the total cost of this heater if the electricity costs 6.5 cents per unit? Okay, I'm going to convert cents. So dollars is equal to 4,320 times 0.065 cents, or dollars, I should say. So we've divided our cents by 100. Oops. Times by 0.065. It's $280.80. Okay. If you left it as cents, so cost in cents is equal to 4,320 times 6.5, which is equal, that would be equal to 2,880 cents. Okay, so you could have left it in cents, but dollars are better. How many joules of energy were used? Okay, so well, one if 1 kilowatt hour equals 3.6 times 10 to the 6 joules, then 4,320 kilowatt hours is equal to 4,320 times 3.6 times 10 to the 6 joules. So it's going to be quite a fair few, I would have thought. So 4,320 times by 3.6 times 10 to the 6 is going to be a lot of energy. So we've got 1.56 times 10 to the 10 joules. That's a lot. 1.56 times 10 to the 10 joules. So that's a lot of energy. Okay. And that is actually the final physics problem that we actually have. All the rest are, there's some more notes after these, so if you can see that this is page 28 of 31. The other ones are more for in-class discussions and things like that. It's useful to read over those examples as well. It is useful to read, so feel free to read over those in your own time. But other than that, feel good about the fact that you've got through all the physics in physical sciences. And yeah, chemistry will be the next half of the year that we have to undertake. All right.